Hello, everyone. So we are starting the second day of the ABP conference. So today we are talking about, we are going to make some talks. So Engincan is going to make the first one. Engincan is from ABP core team member in Volosoft. So he is going to speak about sentiment analysis in .NET. So Engincan, you can start if you wish.
Sure. Thanks, Tarık. Hello, everyone. Today I will be showing you how you can apply sentiment analysis in .NET. As Tarık said, I am one of the core team members of ABP Framework, and I am working as a software engineer at Volosoft. You can follow me on GitHub, Twitter, and you can also follow my personal blog website. Today, this is our agenda. That's the topics that we are covered today. First, I want to show you which options do we have in the .NET side for machine learning, which libraries, tools, or frameworks do we have, and then I will briefly explain you the ML.NET framework, which is created by the .NET and aim to simplify the work to create machine learning modules for .NET developers. Then I will talk about what is the sentiment analysis. This is the main topic of today. And finally, I will create an ABP-based application, integrate CMS Kit's commenting feature, and I will add spam detection by extending the commenting feature. When we talk about machine learning, we generally think about Python as a language. And when we want to create some machine learning models, we use Python and it's one of the frameworks such as Flask and creating the API, creating the model, and expose the API to consume in the .NET application or any kind of application. But as you would understand, this is a cumbersome process because we need to depend on the Python service and we need to communicate with network, and it's not reliable. And at that point, we have some options on the .NET side, and we can directly create our machine learning models in our application. The most popular one is the ML.NET framework, which is created by the .NET team. And it is the officially supported framework, and it's really easy to use. And in today's demo, I will use ML.NET framework and will show you how you can easily apply sentiment analysis. And also, we will talk about some advanced topics such as saving the model and using in the future uses. And also, we have C# Stack, which is a GitHub organization and creates some machine learning models and libraries such as both Sharp, TensorFlow.NET, and other tools like that. And for the third option, we have Accord.NET, which is actually an old framework, and it's not actively maintained and it's archived right now, so it's not frequently used nowadays. And for the fourth option, we have Spark, which is also created by the .NET team, and it is actually .NET for Apache Spark models. And obviously, ML.NET is the official framework and is created by the .NET team. It's a machine learning framework for .NET developers, and it allows us to create machine learning modules easily into our .NET applications. And it allows us to implement all of our logic and scenarios, such as sentiment analysis, like I will show you in this today's demo, or you can make price prediction or image classification or object detection. And at that point, I want to show you the repository of the machine learning framework of .NET. It has almost 9K star. It has really good samples and documentation. You can also check this from the website. When you check their documentation, you will see there is a practical guideline right here that show you how you can load your data, prepare your model, training your model, and predict the data. And also it explains some basics such as the APIs and the module builder, which is a UI tool that you can directly create your machine learning modules in Visual Studio. It also has video tutorials and API references documentations. And beside that, .NET team created machine learning samples repository, which has both community samples, as you can see with the binary classification or object detection, for example, or you can also check the machine learning samples homepage to see the official documentation that's explained and used in the .NET's own documentations. And when I go back to my slide, as you can see, ML.NET framework actually uses a system called AutoML, which stands for as automated machine learning. Normally, when you want to implement a machine learning model, create a machine learning model, you need to have a data, you will load the data, and then you will choose a correct algorithm for your scenario. And then the things you need to do is to train your data and predict the data. But in that process, you're not sure that your algorithm is the right one, is the accurate one. And the AutoML actually automate this process, and it allows you to create the data pipeline for your model with a small amount of code, and it automatically compare the related algorithms and find the most accurate and proper one to use in your application. So it's really help you to automatically select the related machine learning models and algorithms, so you can use it to get benefit of finding the most efficient models. Also, this framework, the ML.NET framework, has some integration with popular libraries such as ONNX, TensorFlow, and Info.NET. It's a really extensible platform and it's well documented. And today I will show you its some APIs, and we will show it on the demo. And today I will use the ML.NET framework, as I just said. And I just wanted to show you a simple application to demonstrate the topic well. And I choose the sentiment analysis. And it is basically all about determining the emotion of the users. For example, in this page, we have two commands. And the first command has 5 rating, and the other one is the 1-star rating. And even if this rating component wouldn't be in this comment section, we could understand the emotion of the user who writes this comment, right? Because if you look at the first comment, it says it's a solid phone. It says it has so many features, and it uses some positive words like or easy to find. And it also says the battery is really good for this phone. And if we look at the second comment, you will, as you will say, it says it's useless. It suggests you to do not buy this phone. So this is what sentiment analysis is all about. We can understand the emotion of the user, or the positivity or negativity of the input from just analyzing it. This is what we call sentiment analysis. And in today's example, I wanted to demonstrate that. And therefore, I've created an ABP-based layered application, and I will show you that, the solution structure and how I integrated the CMS Kit module. And I integrated the CMS Kit module and its commenting feature in my application. And this, as you can see from the Git, allows me to add a comment, delete or edit an existing one. And as you would understand, by default, CMS Kit commenting feature does not make any spam detection. And today we will just simply add this feature. When we add a message content with an obvious spam message, it will say spam detected, and you need to update your comment. And then we can update the comment. And then when we submit the button, it will do the related validations, and it will add it to the database and will show it on the page. And when we think about our application today, the demo application, we will make spam detection, and it has 4 main steps actually. A user needs to make a comment, and after that, in the backend side, we will do sentiment analysis and we'll detect the message, and we'll classify it as either spam or not spam. And then we will evaluate the results. We will get the result, and we will also check the probability of the results accuracy, and then we will determine that should we approve or reject the comments. I have already created a repository and shared this demo in my repository, which you can find in my GitHub profile called Sentiment Analysis Demo. I will also share the links after my presentation. And you can also find today's presentation from my GitHub profile as well. You can check the presentations repository and get the demo and the slides from a single point. And as this is our 4th step to implement and apply our logic, right? And if we look at these 4 steps in the terms of machine learning, we can create a flow, right? For example, to apply a sentiment analysis, obviously we need to make an input. We need to have a data. And I found a data called spam_data.csv. And as you can see, we have 2 columns in this data. One of them is category and the other one is message. And as you can see, message is our input data. This corresponds to our comment that we will add to the comment component. And as you can see, the other column is category and is classified into 2 categories. One is ham and the other one is spam. And after we find the data, and by the way, I found the data from the Kaggle, which is the most popular dataset repository for the machine learning and AI specialists. As you can see, find the CSV file from here, which has more than 5,000 unique value, and I just downloaded it and added to my application, so I can directly use this data set in my application in the demo, and I will also show you that. And after we find the data, the first thing we need to do is load the data in the background, because we need to have this data to train our module and test it. For the second thing, as you can see, we have more than 5,000 data, and we need to split this data into training and testing data. Because after creating our model, we need to evaluate its result. And this is really helpful for us because when we split it to train and test data, after we training by using the training data sets, we can evaluate it with the split test data. So this will give us the accuracy of our model and how performant it is. And after we split the data as training and testing data, for the third step, we can make some data transformations. We need to create a data pipeline. Because as you can see, messages are text-based, and the machine learning algorithms and the models are work best with the numeric values. There are some mathematical operations running behind the scene. So we need to represent all of this text data for this column, for example. For this row, we need to transform this text data to numeric vectors, which means for the keyword like free, we need to represent each word, each sentence as a numeric value within a multiple array. And after we transform this text-based value to numeric vectors, then we can try the related and most correct and performant models by evaluating the results. And after choosing the correct algorithm, the last 2 things that we need to do is training the model, finalizing its result, and predict the result by specifying an input value. And at that point, let's look at our example again, and let's remind it in a simple way. We will have a comment and we will edit, and we want to make some validations behind the scene. and we want to detect the spam if there is a spam key or if the content contains any spam word, and we want to not be able to edit to our page. And at that point, let me show you the code side. I edit the CMS Kit commenting feature. The comment component that you see on the homepage is come from the CMS Kit commenting feature. I didn't make any changes on this UI. And to be able to add the CMS Kit's commenting feature, you first need to add the CMS Kit module into your application because it's not pre-installed by default. For that purpose, you can open the CMS Kit module documentation and scroll down a little bit to find the how to install section. And then you can directly run this command in your solution directory. And after you use it, AVP CLI will automatically add the related projects packages into your layered projects. So you don't have to worry about the configurations. And after that, you need to enable the CMS Kit features that you want to use. You can either enable all of them or you can enable features one by one. And if you look at my code, I just enabled the commenting feature and not enable all of the other features. And if you look at the global feature configurator class, you will see it in the demo shared project. This is already created for you when you create a new ABP solution. So the only thing you need to do is adding this 4 line of code to enable the related feature that you want. Then you need to create a migration if you are using Entity Framework core and apply it to your database. After you added the CMS Kit module and enabled the related features, you can configure the CMS Kit comment options to be able to use the related components in your application. For example, I've enabled the reCAPTCHA, and also I've set an ent type name as the comment because the CMS Kit commenting feature is candidate for using in multiple places, in multiple resources. For example, if you have blog post, you can use comment in this page, and also if you have, for example, a product page, you can also use this component on that page. And after I make the related configurations, then I am ready to add the related components into my page. And if you remember our homepage from here, we have just a header, we have a title, and then we have the related commenting component came from the CMS Kit module. And for that reason, I just need to invoke the commenting view component. And as you can see, I've set the entity type as comment, and I added an entity ID, so it will diverse this component with the other components. And I also am able to set the comment section is read only or not. And then, as you can see, I am able to add comment, delete or edit existing one. And by default, ABP's CMS Kit module does not make any validations, as I've said at the beginning. I want to just extend its behavior and add extra validations. For that reason, we can overwrite the CMS Kit's comment public app service. And as you can see, I am just replacing the services in the dependency injection container. And from now on, when I comment public app service used, it will be use my own service. I am exposing services by using this attribute. And I am just overriding the create and update methods because I want to apply the spam detection in both when creating a new command and updating an existing one. And I just simply add a spam detector service in here, and I am checking the the message, the comment, and detect the spam or not. And if a spam detected, I will throw an exception and will not save it to the database. And I also use this for the update async method right here. And if we examine the spam detector class, this is where the all machine learning model build-up process is going on. As you would remember our steps, we first need to load our data, right? I've already downloaded the data. As I showed you at the beginning of the slide from the Kaggle, and I've just added into my project directory under web project, ML, and data folders. And then I just need to load this data at the first step. Before that, I created the ML context object, which is very similar concept with the EF course DB context object. Everything you do to create a the machine learning model, you are using the ML context. This is the main class that you manage to your application's machine learning process. And for the first step, I define the data path as the spam_.csv, which is corresponding to this file. And as you can see, my data has two columns called category and message. And also it's separated with the comma, and it's categorized into two category. If it's 0, then it means it's not spam content. And if it means it's a spam content. For example, this is the spam content because it has some known words for the spam content like free entry or you win FA Cup finals or such as other examples, things like as text FA2, this number or etc. And to be able to load the data to our backend side, we need to use the load from text file methods. We will specify the data path as the spam data.csv. We will say has header as true because we have header as column and category. And we have a separator char as comma. And after we load the data, we need to map it to an input value so that we can use it later on. And if we look at the input class that we have in here, it has two properties. It's category and messages. And I just specified which column to load and put it to this property. The category will be our first column, and the first column and the message will be our second column. And I also am able to set the column name in my model when I build it. So after I load the data, and if you would notice, it's an IDataView class. It is representing of loading the data in an interface, and it is actually lazy loading, which means until I training my machine learning model, this data will not be downloaded into my memory, will not be saved into the memory. So it's performant, and it will not be saved to the memory. And after I have a data view, which also putting my data, for the second step, I need to split the data into training and testing data sets. Because I need to make evaluations to see my training data is really good and ready to go in my application. And for that purpose, I can use the train test split methods. I just need to specify the data view, and after that, I need to specify a ratio for the testing data sets. Actually, which means that I specified 0.2, which means use all of my data set and split it 80% of it as a testing data set, training data set, and 20% of my data as the testing data set. And after splitting the data, then we need to start choosing the algorithm and make the data processing and data transformations. So we are basically creating the data pipeline. And as you would remember, our data our message data, which is our input data, is text-based value. But as you would remember, machine learning algorithms are not good with the text-based algorithms, and they are work best with the numeric values, numeric vectors. And at that point, we can use the transformers and use the featureized text methods, and we can specify a dummy output column name, which will be our main column name after the transformations. And we can simply define our input, which is the message column in our case. And after this sign is working, it's just basically transforming all messages into numeric values. And after we have the numeric values, we are ready to go to let ML.NET do the mathematical operations for us and run the machine learning algorithms. For that purpose, since we have two possible options for the output, 0 or false, 0 or 1, true or false, or spam or not spam, we can use the binary classification. As the name pretty self-explanatory, the binary classification is good candidate to split the result if it's classified in the two categories, 0 or 1, for example. And we can use the binary classification model, and we can use the SDCA logistic regression algorithm, which is a well-known algorithm, and you just need to use this method, and then you need to specify the label column name, and also you just need to specify the feature column name. And as you would notice, it is features, and it's just same with our output column name that we specified while making data transformations. Because from now on, we don't have a text data, and we are just using the numeric vectors that corresponding to our messages. And after we made the data transformations, we have the numeric vectors, and we choose our models, and we also choose the related training algorithm. Then we can train our models. At that point, we are using the fit API. And when we use this fit API, then the lazy loading of our data view is broken, and all of the data logic and the model build is loading into our memory. So at that point, since we have the model, we are ready to go to get an input from the user and make the validations. For example, we are creating our input class in here and passing the text that the user of our application commented, and we are passing it to our input class. And then we just need to create a prediction engine by specifying the related input and output classes. As you know, the input classes is just the representation of our data set. And if you look at our output model, it just simply holds three values. The prediction is the result for us, is spam or not spam. And for the other two values are actually metrics that we can use in our application to determine that should we approve or reject the comment. And if we go back to spam detector service, as you can see, we are using the predict API, and this return us the results. And we can then finally make it, is this content is a spam check. And as you would notice that we are not just depending on the prediction. And if the content is spam, okay, the prediction will be true, but we should also ensure that the probability is high. For example, I'm checking if its probability is greater than 50%. In the normal models, you will probably try with the 80% or 90%. And this is all of our application, and let's run it again and try to add a new comment and try to add a spam content, and let's see if it detects spam or not. Let me run the application. Until the application started, I also want to show you a more advanced topic. When I was explaining you the real process, I just simplified the process actually, because when you want to create a machine learning model, you need to check its accuracy. You need to evaluate your model and ensure that your model will be good enough and will be a good candidate for your scenario. For example, after you training the model, you should be able to evaluate it. And for that reason, you need to evaluate your model before predicting the final result. And for that reason, you can use the testing data and make the same transformations that you applied to the training data sets. And then you can use the binary classification and the evaluate method, and then you can pass the data and specify the label column and the score column names. And after you that, this evaluate method will create an calibrated binary classification metrics, and then you can use and check some metrics. For example, you can evaluate you can get the result of the accuracy of your model, and it's 0.7997 in our case. And also you can get the advanced score, which is a really important metric, and it's indicate that how performant your model, how performant your binary classification model is. And it's 91% in our case. And these are really good values to be used. And we can use these metrics to evaluate the results. And let's see our application first, and then I will show you one more thing. Okay, I will first try to add a spam content. And as you would see, it has some obvious spam context and keywords such as winner, you get a free entry, and so on. And I write the comment, specify the captcha, and when I click the send button, the spam detection will be run on the background, and we will see if it passed or not. As you can see, the spam is detected and the exception is thrown, and it suggests me to update the message. And let's update the message and just say FA final pop. And when I try to add this content, let's see if it's added to my comment page. And as you can see, it made the related validations, and then it added my comments into the related comment section, and then I'm ready to go to add a new comment if I want. This is today's demo, and I just want to show you one more thing. And if you look at our spam detector service from the outside, you will notice that we are always first loading the data, splitting the data into training and testing data sets, then making some data transformations, and then we are choosing and setting the related training algorithm, and then finally we are training the model and make the related prediction. But this is not a good way to do this, because to loading the data in each time and training and using the data is not good for your hardware of your services. And normally in a production ready code, you after you first build your model, you first training the model, you should be able to save and persist the trained model, trained data into a zip file. And it is really easy to do this with the ML.NET framework. You just need to use the model.save methods. In right here, you will use the model that you trained, and you will specify the training data.schema. This means the input column name actually, which is the message in our case. And after you specify the model and schema, you need to define the path that will be saved into your disk. And as you will see that I have defined the zip file name as spam data model.zip, and it's under the ML and data folders. And then I will save and process the trained model. And this will be saved as a zip file when I first run the application. And since we already run our application, and it created the model, built the model, and saved the models in the 45th line. As you can see, it created the .zip file. And if I open this file in a file explorer, and okay, as you would see, you can see my zip file, and let me unzip it. Okay, and you can then check the folders and files in here. We have a schema file, which is just holding the input file, input column name. And we also have training info and transformer chain folders. The training info folder just have a version.txt file, which holding the version information of the NuGet package that we are using right now. And let me also show you that we are using 3.0.1, which is the latest stable version of the Microsoft.ml NuGet package. And if I open the application.csposh file, you will see the Microsoft.ml package with the version. And this version.txt file just simply holding that, so the model will know the version and will run its logic according to the version. And also, I have a transformer.chain folder. This is what everything is storing. Actually, this is the heart of our model. It has a model.k file. It has two main transformers, which is corresponding to our, let me show you, our featurized text transformer and the logistic regression algorithm that we are using. So these are the two main transformers that we are using in our model. And if I open it, you will see, if I look one of them, you will see there are other chains. So even I use just one transformer and featurize the text into numeric vectors, it runs multiple algorithms and transformers under the hooks. And ML.NET framework actually is really have benefit at that point. We don't need to worry about all of this stuff. We just need to have the zip file. And if we have the zip file, then we can check if the file exists in the disk. And if it exists, this means we have a training model. And then instead of loading the data, splitting it into training and testing, and training the model, we can directly load the model from the model path. And we can also get the input schema if we want to make an additional operations. And then after we have the model, we can do the prediction as always. We just need to have the input, and then we can create the prediction engine, and we can get the results. And finally, we can compare the related results and check if it's good to go with our models. And that was actually all from me today. I will share the related links for you, links with you. And okay, I guess we have 5 minutes. If there is any question, I can answer this one. Let me check. About ML.NET is a good option, or is better create a Python API microservice and call it from .NET service. Actually, when I create a machine learning models, I generally use Python, and I was using Python and Flask, especially when I was in university. but I wasn't expecting that the ML.NET framework would be so much easier and easy to build up a model and use it in my application. It is a really good choice, and it's a really good documentation as far as I see. And I've created multiple application. I've tried it and examined its code, and it has a really good structure. And I think you should give it a go. And if I were you, I would go with the ML.NET framework. iTransit okay. About performance, you use the iTransit dependency. Can you switch to singleton? Yes, you can, but as I said, if you want to make your model, make your service performant, of course, changing its life cycle is a good way, but you just need to zip your model after you first created it, and you need to load the zip file after the next call, and it will be more performant. And yes, but yes, you can make it singleton service. Okay, can we directly use models from Kaggle with the ML.NET library to another process beforehand? No, actually, you can directly use the ML library with any data you want. And in today's example, actually, I just downloaded this data, and I just, as you would notice, the category is ham and spam in here. I will just change this data as 0 and 1 to make it more easy to understand and apply. And then I directly loaded the data in my application and create my models. And then, is there any other question? Okay, no, it's not happening each time. If you save it to a zip file and load it in the next call, it will not be training in the each time. So it's really good and easy to use in this way. And there's one more question. Okay, that was all from me today. As far as I see, there is not any question left. Thanks for listening, and we are ready to end the session. Thanks for all.
Thank you, Engin.
you.
So such a great presentation from you. So I would like
you.
to remind all the attendees about do not forget to join the, actually not joining, do not, I'm going to share my screen to make it more understanding. So we are going to make some raffles today. So you don't need to register for that, but we are going to make this drawing from the attendees, between the attendees. So we would like to thank the sponsors who are iTechnologies, JetBrains, and PacT, of course, Volosoft and the Mailtrap. So we are going to make them happen at the end of the day. Thanks for this great presentation, Engin.
Thank you, Tarek.